The 1999 edition of NFPA 72 does not prohibit smoke detectors on ground fault circuit interrupter or GFCI protected branches. It is possible that a prior claim might have been based on a misunderstanding of a previous code cycle or perhaps an error in interpretation. In the 1999 National Electrical Code, specifically section 210.12b, it clearly states that the grounding conductor shall not be used for any other purpose. This stipulation emphasizes that the grounding conductor cannot be used as a pathway to carry current from the GFCI to the smoke detector. However, it is crucial to recognize that this regulation does not inherently mean that smoke detectors cannot be installed on GFCI protected branches. In fact, the 1999 NEC specifically allows smoke detectors to be installed on GFCI protected branches as outlined in section 760.41a. This section explicitly states that smoke detectors shall be installed in accordance with 760.41a on thoroughfare. Further breaking down the specifics, section 760.41a directly states that smoke detectors shall be installed on a branch circuit that is protected by a ground fault circuit interrupter, otherwise known as a GFCI. Therefore, based on these references, it becomes very clear that the 1999 edition of NFPA 72 does not prohibit smoke detectors on ground fault circuit interrupter protected branches. The main takeaway is to understand the stipulations regarding ground fault circuit interrupters and smoke detectors. In order to understand the relationship between ground fault circuit interrupters and smoke detectors, firstly, it is important to define what a ground fault circuit interrupter actually is. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing in a circuit and quickly interrupting the power supply if it detects an imbalance. This imbalance typically occurs when current leaks to ground, which can happen if someone touches a live wire or if there is a fault in an appliance. GFCIs are commonly found in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. They provide an essential layer of protection against electrical hazards. Secondly, it is important to define what a smoke detector is. A smoke detector is a crucial fire safety device designed to detect the presence of smoke, which is often an early indicator of a fire. When smoke particles enter the detector, it triggers an alarm alerting occupants to the potential danger. Smoke detectors are typically installed in homes, apartments, and commercial buildings to provide early warning and allow for timely evacuation. They can be powered by batteries or hardwired into the electrical system, often with a battery backup in case of power outages. Regular testing and maintenance of smoke detectors are essential to ensure their proper functioning and to keep occupants safe from the devastating effects of fire. Thirdly, the National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and serves as the basis for electrical codes in most jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Its primary goal is to protect people and property from electrical hazards by ensuring that electrical systems are installed and maintained in a safe and reliable manner. Compliance with NEC is essential for electrical contractors, inspectors, and anyone involved in electrical work to ensure safety and prevent electrical fires and other accidents. Fourthly, NFPA 72, the National Fire Alarm and Signaling Code, is a comprehensive set of standards and guidelines for the installation, testing, and maintenance of fire alarm systems and equipment. It covers a wide range of topics, including system design, component selection, wiring methods, and emergency communication. NFPA 72 aims to ensure that fire alarm systems are reliable and effective in detecting and alerting occupants to fire emergencies. It is used by fire protection engineers, installers, inspectors, and building owners to ensure the proper functioning of fire alarm systems and to protect lives and property from the dangers of fire. Regular updates to NFPA 72 incorporate new technologies and best practices to improve fire safety and emergency response. The relationship between ground fault circuit interrupters and smoke detectors has evolved over time, leading to some confusion and debate. In earlier editions of electrical codes, there were concerns about connecting smoke detectors to GFCI protected circuits. The primary concern was that a ground fault in the smoke detector circuit could trip the GFCI, potentially disabling the smoke detector and leaving occupants unprotected during a fire. This concern was valid because early GFCIs were more prone to nuisance tripping, and smoke detectors were considered critical life safety devices that should not be easily disabled. However, as GFCI technology improved and became more reliable, and as smoke detector technology also advanced, the codes began to evolve to address these concerns. Modern GFCIs are designed to be more resistant to nuisance tripping, and smoke detectors are now often equipped with battery backups to ensure they continue to function even if the main power supply is interrupted. Furthermore, the NEC now includes specific provisions that allow for the installation of smoke detectors on GFCI protected circuits under certain conditions. These provisions typically require that the GFCI be specifically listed for use with smoke detectors and that the smoke detectors have battery backups. Additionally, some jurisdictions may have local codes or regulations that further address the installation of smoke detectors on GFCI protected circuits. Firstly, smoke detectors are life safety devices. Smoke detectors play a critical role in saving lives by providing early warning of a fire. Their primary function is to detect smoke particles in the air and trigger an alarm, alerting occupants to the presence of a fire and giving them time to evacuate. Smoke detectors are typically installed in homes, apartments, and commercial buildings to provide around-the-clock protection. They can be powered by batteries or hardwired into the electrical system, often with a battery backup in case of power outages. Regular testing and maintenance of smoke detectors are essential to ensure their proper functioning and to keep occupants safe from the devastating effects of fire. Secondly, ground fault circuit interrupters provide electrical safety. Ground fault circuit interrupters, GFCIs, are essential electrical safety devices designed to protect people from electric shock. They work by monitoring the current flowing in a circuit and quickly interrupting the power supply if they detect an imbalance. This imbalance typically occurs when current leaks to ground, which can happen if someone touches a live wire or if there is a fault in an appliance. GFCIs are commonly found in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. By quickly cutting off the power, GFCIs can prevent serious injuries or even death from electric shock. They are an important part of any electrical safety plan, especially in areas where water and electricity may come into contact. Thirdly, code compliance is required for electrical installations. Code compliance is a critical aspect of electrical installations, ensuring that all wiring and equipment meet safety standards and regulations. Electrical codes such as the National Electrical Code, or NEC, set forth specific requirements for the installation, maintenance, and inspection of electrical systems. These codes cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with electrical codes is essential to protect people and property from electrical hazards, such as fires, shocks, and explosions. It also helps to ensure the reliability and longevity of electrical systems. Electrical contractors, inspectors, and homeowners must all be familiar with and adhere to applicable electrical codes to ensure the safety and proper functioning of electrical installations. Fourthly, battery backups ensure smoke detector operation. Battery backups play a crucial role in ensuring the continued operation of smoke detectors during power outages. Smoke detectors are essential life safety devices that rely on a continuous power supply to detect smoke and trigger an alarm. When the main power source is interrupted, such as during a power outage, the battery backup automatically takes over, providing power to the smoke detector so that it can continue to function. Battery backups typically consist of a rechargeable battery that is constantly charged by the main power supply. When the power goes out, the battery seamlessly switches on, allowing the smoke detector to remain operational until the power is restored. Regular testing and maintenance of battery backups are essential to ensure their reliability and effectiveness in protecting occupants during emergencies. The NEC addresses the installation of smoke detectors on GFCI protected circuits in specific sections, providing guidelines to ensure both fire safety and electrical safety. Section 210.12 of the NEC covers arc fault circuit interrupter protection, or GFCI, and ground fault circuit interrupter protection, or GFCI, requirements for dwelling units. While this section primarily focuses on the types of circuits that require GFCI and GFCI protection, it also indirectly addresses the installation of smoke detectors on these circuits. It is important to ensure that smoke detectors are installed in accordance with the manufacturer's instructions and any applicable local codes, in addition to the NEC requirements. Section 760.41 of the NEC provides specific requirements for the installation of fire alarm systems, including smoke detectors, in dwelling units. This section outlines the acceptable wiring methods, circuit requirements, and grounding requirements for fire alarm systems. It also addresses the use of GFCIs in fire alarm circuits, allowing for their use under certain conditions. Specifically, Section 760.41A3 permits the installation of smoke detectors on GFCI protected circuits, provided that the GFCIs are specifically listed for use with fire alarm systems and that the smoke detectors have battery backups. This provision recognizes the importance of both fire safety and electrical safety and allows for the use of GFCIs in fire alarm circuits without compromising the functionality of the smoke detectors. The interpretation of these NEC sections is crucial for ensuring the safe and effective installation of smoke detectors on GFCI protected circuits. Firstly, the NEC permits smoke detectors on GFCI circuits under specific conditions. The NEC does allow for the installation of smoke detectors on GFCI protected circuits, but only under certain conditions. These conditions typically include the use of GFCIs that are specifically listed for use with fire alarm systems and the requirement that the smoke detectors have battery backups. The intent of these requirements is to ensure that the smoke detectors will continue to function even if the GFCI trips or there is a power outage. Secondly, GFCIs must be listed for use with fire alarm systems. One of the key requirements for installing smoke detectors on GFCI protected circuits is that the GFCIs must be specifically listed for use with fire alarm systems. This listing ensures that the GFCIs have been tested and certified to meet the unique requirements of fire alarm circuits, including their ability to provide reliable protection without causing nuisance tripping. Listed GFCIs are designed to be more resistant to false alarms and are less likely to trip due to transient voltage spikes or other electrical disturbances. Thirdly, battery backups are essential for continuous operation. Battery backups are an essential component of smoke detectors installed on GFCI protected circuits. The battery backup ensures that the smoke detector will continue to function even if the GFCI trips or there is a power outage. This is critical for ensuring that occupants are alerted to fire, even when the main power supply is interrupted. Battery backups typically consist of a rechargeable battery that is constantly charged by the main power supply. When the power goes out, the battery seamlessly switches on, allowing the smoke detector to remain operational until the power is restored. Fourthly, local codes may have additional requirements. In addition to the NEC requirements, local codes and regulations may have additional requirements for the installation of smoke detectors on GFCI protected circuits. These local codes may vary depending on the jurisdiction and may include specific requirements for the type of GFCIs used, the location of smoke detectors, or the testing and maintenance of smoke detectors. It is important to check with local authorities to ensure compliance with all applicable codes and regulations. To properly install smoke detectors on GFCI protected circuits, firstly, select listed GFCIs designed for fire alarm systems. When installing smoke detectors on GFCI protected circuits, it is essential to select GFCIs that are specifically listed for use with fire alarm systems. These GFCIs have been tested and certified to meet the unique requirements of fire alarm circuits and are designed to provide reliable protection without causing nuisance tripping. Look for GFCIs that are labeled as being suitable for use with fire alarm systems and that meet the applicable UL standards. Secondly, ensure smoke detectors have functioning battery backups. Before installing smoke detectors on GFCI protected circuits, make sure that the smoke detectors have functioning battery backups. The battery backup ensures that the smoke detector will continue to operate even if the GFCI trips or there is a power outage. Test the battery backup regularly to ensure that it is functioning properly and replace the battery as needed. Thirdly, follow manufacturer's instructions for installation and wiring. When installing smoke detectors on GFCI protected circuits, it is important to carefully follow the manufacturer's instructions for installation and wiring. These instructions will provide specific guidance on how to properly connect the smoke detector to the electrical circuit and how to ensure that it is functioning correctly. Pay close attention to the wiring diagrams and any specific requirements for the type of wiring or connectors used. Fourthly, test the installation after completion to verify functionality. After completing the installation of smoke detectors on GFCI protected circuits, it is essential to test the installation to verify its functionality. Test the smoke detector by pressing the test button and ensuring that the alarm sounds. Also, test the GFCI by pressing the test button and verifying that it trips the circuit. If the smoke detector or GFCI does not function as expected, troubleshoot the installation to identify and correct any problems. Regular testing of the installation is essential to ensure that it is functioning properly and providing adequate protection. Common misconceptions about ground fault circuit interrupters and smoke detectors often lead to confusion and potentially unsafe installations. Firstly, all GFCIs are suitable for smoke detector circuits, which is incorrect. One common misconception is that all GFCIs are suitable for use in smoke detector circuits. However, this is not the case. Standard GFCIs are designed to protect against electrical shock in general-purpose circuits and may be prone to nuisance tripping when used with smoke detectors. Only GFCIs that are specifically listed for use with fire alarm systems should be used in smoke detector circuits. Secondly, GFCIs guarantee smoke detector functionality during power outages, which is also incorrect. Another misconception is that GFCIs guarantee smoke detector functionality during power outages. While GFCIs provide protection against electrical shock, they do not provide backup power in the event of a power outage. Smoke detectors must have battery backups to ensure that they continue to function during power outages. Thirdly, battery backups are unnecessary if a GFCI is present. Some people believe that battery backups are unnecessary if a GFCI is present in the circuit. However, this is not true. Battery backups are essential for ensuring that smoke detectors continue to function even if the GFCI trips or there is a power outage. The GFCI protects against electrical shock, while the battery backup ensures continuous operation of the smoke detector. Fourthly, local codes always prohibit GFCIs on smoke detector circuits, which is incorrect as well. Another misconception is that local codes always prohibit the use of GFCIs on smoke detector circuits. While some local codes may have restrictions on the use of GFCIs in smoke detector circuits, the NEC permits their use under certain conditions. It is important to check with local authorities to determine the specific requirements in your area. The benefits of using ground fault circuit interrupters with smoke detectors include electrical safety, code compliance, and enhanced protection. Firstly, ground fault circuit interrupters provide electrical safety. Ground fault circuit interrupters, or GFCIs, provide an important layer of electrical safety by protecting against electrical shock. When used in conjunction with smoke detectors, GFCIs can help to prevent electrical hazards in the event of a fault in the wiring or equipment. This is especially important in areas where there is a high risk of water exposure, such as bathrooms and kitchens. Secondly, the installation ensures code compliance. The use of GFCIs in smoke detector circuits can help to ensure compliance with electrical codes, such as the NEC. The NEC permits the use of GFCIs in smoke detector circuits under certain conditions, provided that the GFCIs are specifically listed for use with fire alarm systems and that the smoke detectors have battery backups. By following these requirements, homeowners and installers can ensure that their installations meet the applicable code requirements. Thirdly, this installation enhances protection against electrical hazards. GFCIs enhance protection against electrical hazards by quickly interrupting the power supply in the event of a ground fault. This can help to prevent electrical shock and reduce the risk of electrical fires. When used in conjunction with smoke detectors, GFCIs provide a comprehensive safety solution that protects against both fire and electrical hazards. The potential drawbacks of using GFCIs with smoke detectors include nuisance tripping, increased cost, and complexity. Firstly, nuisance tripping is possible. One potential drawback of using GFCIs with smoke detectors is the possibility of nuisance tripping. GFCIs are designed to trip when they detect a ground fault, which can sometimes occur due to transient voltage spikes or other electrical disturbances. If a GFCI trips frequently, it can be a nuisance and may lead to occupants disabling the smoke detector, which can compromise fire safety. Secondly, increased costs might occur. The use of GFCIs in smoke detector circuits can increase the cost of installation. GFCIs are typically more expensive than standard circuit breakers, and the requirement for listed GFCIs specifically designed for fire alarm systems can further increase the cost. Additionally, the installation of battery backups in smoke detectors can add to the overall cost. Thirdly, it increases complexity. The installation of GFCIs in smoke detector circuits can add to the complexity of the installation. GFCIs require proper wiring and grounding to function correctly, and the requirement for listed GFCIs specifically designed for fire alarm systems can make the installation more challenging. Additionally, the installation of battery backups in smoke detectors requires careful attention to ensure that they are properly connected and functioning correctly. Regular maintenance and testing of smoke detectors and GFCIs are essential to ensure their proper functioning and to maintain a safe environment. Firstly, regular testing of smoke detectors is important. Smoke detectors should be tested regularly, typically once a month, to ensure that they are functioning properly. This can be done by pressing the test button on the smoke detector and verifying that the alarm sounds. If the smoke detector does not sound, the battery should be replaced or the unit should be inspected for any other problems. Secondly, battery replacement is important. The batteries in smoke detectors should be replaced at least once a year, or more frequently if the smoke detector indicates that the batteries are low. It is a good practice to replace the batteries in all smoke detectors at the same time each year, such as when changing the clocks for daylight savings time. Thirdly, regular testing of GFCIs should also be done. GFCIs should be tested regularly, typically once a month, to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI and verifying that it trips the circuit. If the GFCI does not trip, it should be inspected by a qualified electrician. Fourthly, perform visual inspections. In addition to testing, smoke detectors and GFCIs should be visually inspected regularly to ensure that they are in good condition and free from any damage or obstructions. Look for any signs of corrosion, loose wires, or other problems that could affect their performance. The 1999 edition of NFPA 72 does not prohibit smoke detectors on GFCI protected branches. Understanding the code requirements, potential misconceptions, benefits, and drawbacks is essential for ensuring electrical and fire safety. Remember to consult with qualified professionals for any electrical work to ensure compliance with applicable codes and regulations.